Welcome back everyone. In this lesson, we are going to be looking at setting up our navigation region. Now, a navigation region is essentially a node which defines the areas that our navigation agents can walk on. Now, our navigation agent is basically a thing that wants to get from one point to another while avoiding obstacles. Now, our units are going to be navigation agents, and in order for them to walk around, they need to know where they can walk, okay? Because otherwise, they'll just go from point A to point B in a straight line. So what we have to do is define the walkable area for our units. Now, to do this, we're going to go ahead and create a navigation region 2D node right here and create that. Now, the navigation region 2D, you see it has a little exclamation mark, and this is because we need to actually create a navigation polygon resource. So if we go over to the inspector on the right hand side, you can see here that we have a navigation polygon, and this here is essentially going to be the area or the bounds of our walking abilities. So we're going to click on the arrow here and create a new one of those. Now, to actually draw this, what we're going to do is with the navigation region 2D selected, we're going to click at the top left corner of where we want our characters to be able to walk, and it will create a little point. We then want to go over to the right, create another point here, then create another one down at the bottom and one on the right, and then we're going to go back to the one at the top. And that right there is going to create our navigation region. And then you can see after a second or so, it is going to create this blue square. Now, this blue square is essentially going to be the walkable area. So you can imagine our unit is standing here. Let's actually go ahead and get one out just to show you a little example. So go characters, dragging a character here. Okay, so you can basically imagine this as our character can exist, or it can actually exist anywhere, but it's only going to be able to calculate a path if it is within the bounds of this blue square right here. So let's say our character is here and we want to move over to the middle of the screen. Well, it's going to calculate a path as it is all on the blue, and it's going to move us here. Now, let's just say we want to calculate a path off screen over here. Well, that's not going to be possible, so it's going to calculate it probably to the closest, so somewhere around here. So we're going to move to this bounds of the screen. Now, what we don't want to do is be able to walk through these pylons here, or these obstacles, because that kind of defeats the entire purpose of having a navigation region if we are just able to walk straight through these. So what we need to do is find out a way to basically carve different squares outside of this navigation region polygon. How do we do that? Well, we have to use what is known as a navigation obstacle node. So as a child of navigation region, now it doesn't have to be a child, but I think it's just a bit of a neater setup if we have all of the obstacles as a child of the region. We want to create a navigation obstacle 2D. So we're going to create that. And then what we're going to do is, just like before, we can click and drag to basically create our selection. So what I'm going to do is I'm going to select the navigation obstacle 2D, and I'm then going to click down here, click, and click, and there we go. Now, you'll notice that it hasn't actually done anything to our blue nav mesh visual here, and that's because we need to actually, first of all, select the navigation obstacle, and then in the inspector, open up navigation mesh, and inside of navigation mesh, we have to enable affect navigation mesh and carve navigation mesh. This is going to basically mean that it can affect navigation mesh, meaning it can change the way it works, and carve means it's going to dig out a hole for us to then walk around. Now what we need to do is select our navigation region 2D, and at the top there is this bake navigation polygon button. We want to click that, and that is basically going to carve this out like so. Okay. Now, one thing you may notice is that for our main navigation region, the blue nav mesh is kind of a bit off-centered from the corners. Okay, you can see there is sort of this padding of about, I'd say maybe 8 or so pixels around the outside. This is basically there as a safety margin, because if I drag in my example character again, everything with the navigation is going to be based off its origin. So you can see here the origin of the sprite. And essentially, if we want to move along the corner as far to the left as we possibly can, this is going to be the furthest we can possibly move, because you can see our point here is right at the edge of this nav mesh. Now imagine if our blue nav mesh was hugging right into the corner of this wall. Well, that means our character would be moving here if we were telling them to move along the wall, which is not what we want. We don't want them to be going past the wall. So what we need to do is basically make this distance between the navigation mesh and the edge to be basically the radius of our character. Okay, so we could in fact move make the margin a bit less, maybe 1 or 2 pixels less, but we probably want to keep it at a nice safe margin so we don't ever see our characters clipping over the edge. Now the same thing goes for this obstacle here. You can see that the obstacle is actually hugging the exact bounds that we have defined, which is going to be an issue because let's just say we have our character here and we want to move them from here to here. Okay, that's going to calculate a path which is going to look something like this. Now you can see our character is going to sort of clip just into the pylon here, and that's because it is going to hug as close as it possibly can to the nav mesh as it moves around. So what we want to do is in fact move the bounds of this obstacle out a bit more. Okay, so we will probably want to have the bounds be up to where this character, where their head is right here. So what we're going to do, we're going to delete that. We're then going to open up our navigation obstacle 2D, and we are going to delete these vertices. Now to do that, we can simply go over to the inspector, and where we have the vertices property, we're going to click on the undo arrow right here, which is going to delete them. Now what we can do is go in and create them again. So let's click over here. Oops, navigation obstacle 2D, select vertices, and then we want to click, might want to click over, let's say here, down here, over here, and then back up here. Okay, it's a bit of not a clean job as you can see, but if you want to go ahead and maybe redefine these in more detail, we can go over to the inspector, open up this vertices array here, and manually go ahead and define them as you can see. So for this bottom left one, we probably want to make that to the right a little bit. So I have down here, -119, we're going to make that -118. And there we go, that is going to reposition it here. We might also want to move these over to the left a little bit as well, or if you want to actually have a more hands-on approach, we can go to the top of the screen, and you can see we have these different point tools. We have create point, we have edit points, and we have erase points. Now if we click on the middle one, the blue edit points button, this is going to allow us to click and drag on our points to basically move them around just like this. And then once you're happy with the results, I want to move this down a little bit here. Okay, something like that. We can then go to our navigation region 2D and click bake. And there we go. Now, we aren't going to go ahead and redraw these polygons for every other pylon. Instead, what we're going to do is we are going to select our navigation obstacle node here. We're going to go press W to go to the move tool, and we are just going to duplicate it. So Control D. We can then move this to position over the other one here. Control D on that. Move this one down here. And then Control D on that one, and move this one over here. Okay, now if we go back to the navigation region and bake it, you can see all of them are going to be baked out as you can see here. So now we have our navigation region defined, as well as carving out all the areas we don't want our units to be able to walk. So the next step, of course, is going to be creating our units and having them navigate around this environment. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be setting up our unit base scene. This is essentially going to be the scene that is going to represent the unit for both our player and our AI. Then with that base unit scene, we are going to create multiple inherited scenes for both our player and our AI, and each of them will feature their own unique nodes. But for starters, let's create our unit base scene. So what we're going to do is we're going to create a brand new node over here of type Area 2D. Now an Area 2D is essentially going to be a node that can detect collisions. Now in our case, we're going to only do it with our mouse clicks, okay, because typically with a character you want to move around and bump into things, you would use perhaps a character body 2D, which has physical contact, physical collision, whereas Area 2D allows colliders to pass through one another, rather acting more as triggers or area detectors. Because since we are going to be moving our units along this nav mesh, setting up collisions isn't really that necessary. Okay, so that is why we are not using something such as a rigid body or a character body 2D node. I'm going to rename this area 2D to be our unit underscore base. So unit underscore base. And then what we can do is begin adding in its different nodes or different properties. So first things first, we need a sprite to actually make this look like something. So I'm going to go down to the sprites folder, open up characters, and we can just go down and find something that we think looks good. So we might drag in this knight looking texture here, or this knight sprite, make them a child of unit base. We're then going to rename this node to be sprite, just so we can easily see what it looks like, or easily see what it is later on, especially if we are referencing it in script. And then we want to center its position. So let's go to the transform and set the position to be 0, 0. There we go. Now the next step is we're actually going to go ahead and save this as a scene so that we can edit it in its own individual scene environment. So I'm going to go to unit base, I'm going to open up my scenes folder and drag that into the scenes folder like so, and call it unit underscore base. There we go. Now we can open up our scene by double clicking on it down in the file system, and we can then begin adding in the rest of the nodes it requires. So you'll see that we have this little error message here. This is basically saying that we need a collision shape node on this, because in order for an area 2D to work, it needs a collider, or we need to define the bounds of the collider. So we're going to right click, go add child node, and we are going to search for collision shape 2D. We then want to go over to the inspector and set the shape to be a circle. Now we can resize the circle to however we wish, so maybe something like this, and there we go. Now this doesn't have to be exact, okay? This is only really here for us to be able to detect clicks on them, okay? So as long as it covers pretty much the entire sprite, any size and any position should be good enough. Now the next node we are going to do is set up a navigation agent 2D node. Now this is going to basically give this node, or give this character, the ability to move around on the nav mesh here. So to do this, we're going to create a new node of type navigation agent 2D. Okay, now we're not going to actually be messing with any of these settings just yet. As you can see, there's quite a lot of stuff for us to work with, but for now we're just going to leave all of this alone, and we'll focus on that more when we actually start moving our unit around. Now the final node we're going to add is going to be a health bar, which is going to appear above our unit's head when they begin to take damage. So for this, I am going to simply create a progress bar right here. I'm going to rename it to be health bar, just like so. Alright, so by default, it looks a bit strange. So what we need to do is a number of things. First of all, we want to disable show percentage, because we don't want that percentage in the middle. If you do, you can, but for me, I don't think we're going to have that. We can then stretch this out. Now, if we go down to where we have the value property and set this to be 50, you can see it is going to fill in 50%. If we bring that to 20, it's going to be 20%. Now this is defined by the min and the max value, okay, so basically a percentage between these two. So if we set this to maybe 60, it'll be 60% the way through. Now, of course, we need to make this smaller, but if we make it smaller, you will notice that it gets kind of strange in its size, and we can't actually really make it any smaller than this. So what we're going to do is actually change the scale of the bar instead of its actual bounds, just for now. So if we go over to layout, and then down to transform, you can see here we want to define the scale, and I'm going to set this to be 0.1 on both axes. Now this is going to be a lot easier to work with, and we're going to have a lot more resolution when working with this health bar. So for the size, I'm going to set the size to be 200 by 40, and then we can position it just above our character's head about here. There we go. Now we also need to change the colors, because right now we don't really want this white color on this light gray background that's a bit translucent. We want to have this as solid colors with a bit of a border as well. So to do this, we are going to go down to where we have our theme overrides, and we're going to open up styles. Now for the background, we're going to click on this arrow and create a new style box flat. This we can open up and then choose the background color. I'm going to make this a darkish grey like so, and then for the fill, we can create one here. This here is going to be a red, okay, so we can change the color values here, get a nice reddish color, something like that. Okay, and there we go. Now, we might also want a bit of a border along this background because otherwise the red might blend in with the orange background here. Oops, let's just save this first. As you can see, the red may blend in with the background a little bit, so let's add a nice thick border around this. And to do that, we're going to go down to where we have our red fill here, go down to border width, and change this on the left to be 5 pixels by 5 by 5 by 5. So now we have a 5 pixel border around this sprite, but we don't want it to be white. We want it to be the same color as the background. So I'm then going to open up the border drop down, and where we have color, I'm going to click on it, and I'm going to click on this little eyedropper tool, and then select the background here. And there we go. So now we have our health bar with a nice little border around it. If we go back to our main scene, you can see this is what it looks like. And if we press play, this is what it looks like here. So now that we have our base unit set up, in the next lesson, we can actually begin by setting up its script, which is going to control its health, its movement, and all of the other functionalities this unit is going to need. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to begin setting up our unit script. Now this script is going to basically control all the base aspects and mechanics of our unit, such as moving to a target or moving to a target position. It's going to manage attacking, it's going to manage health, taking damage in of itself, and all those different things. And then in a future lesson, we are going to go ahead and specialize with player units and AI units to basically branch them off from this main script. But 95% of all the code we are writing for our unit is going to be in this base unit script, okay? So let's go over to our unit base scene. And then on our unit base area 2D node, we are going to create a new script. And this script is going to be called unit, and we're going to store it inside of our scripts folder. So unit, and then we can create that. Now, the first thing we are going to do in this script is to give it a class name, okay? So if I go class underscore name and then call it unit, that is us defining this script as a class name. Now, why do we need this? Well, in future lessons, we are going to need to reference this unit or reference a unit. Now, we could do that by just referencing a node 2D or an area 2D, something generic like that. Or we can be more specific and reference specifically this unit script, so then we can call functions and variables onto it. So that's why we are defining a class name here. This isn't really going to change the way this script is going to work, but rather give us a name that we can latch onto and reference later on. Next, we are going to define 2 signals. Now, these signals are going to be called when certain things happen. You can think of a signal like an event, or we've already used signals before in the past. If we go to our node panel and select a node, all of these things here are signals: area entered, mouse exited. These are things that basically get emitted once they have occurred. So for example, when we take damage, we are going to emit a signal that tells whatever is listening that we have taken damage. So I'm going to write down signal and then give it a name on take damage. And then in brackets, we can send over some parameters such as the health, which might be of type int. So when we take damage, we basically are going to emit a signal, and we are going to have another script which is going to which is going to take care of our unit's health bar, and that script is going to listen for this on take damage signal to update the health bar. We then want another signal called on die, and this is going to send over the unit that has died, okay? And we are sending over the unit as of type unit here. So this is going to be listened by our game manager and is going to be used in order to determine if the player or the AI has won the game, okay? So whenever a unit has died, they're going to check to see how many units are left alive in the scene. Now we can move on to our variables. So we're going to start with an export variable called move speed. Now this is export because we want to be able to modify this inside of the inspector. It's going to be of type float, and by default we'll just make this 10. So move speed is essentially how many pixels per second do we want to move, and as you can see, it is going to appear here in the inspector. Next, we want to create a variable for our current HP, which is going to be of type int, and we'll make that 20 by default. So current HP is basically just going to be how much HP we have at the moment, and likewise we want to have a max HP variable, okay, of type int. Then we're going to have some attacking variables, Our first one is going to be one for our attack range. So how far away does this unit have to be from its target before it begins attacking? That is going to be 20 pixels. Let's actually separate these by new lines. We then want to have another variable. This one is going to be called attack rate, and this is going to basically be the minimum amount of time allowed between attacks. So by default, we'll make this 0.5, so essentially this unit can attack twice per second. Now, in order to keep track of when we last attacked, we're going to create a variable here, not an export variable, because this is going to be set in script, and it's going to be called last attack time of type float. Okay, just like that. And then finally, we want to have a variable for attack damage. So how much damage is this unit going to deal to its opponent when it attacks? We'll make that 5. Next, we want to have a variable that keeps track of the players of the unit's team. Okay, are they on team player or are they on team AI? And this is going to be useful for when we are wanting to determine if one unit can attack another. Okay, so for this, we're going to create something known as an enumerator. Now, an enumerator is basically a data type where we define the types that it can be. So for example, a float can be a floating point number, an integer can be any whole number, a boolean can be either true or false. Now, an enum is basically our own custom data type, but we can specify exactly the different values it can be assigned to. So to do this, we're going to write enum, then give it a name. I'm going to call this one team. And then inside of 2 squiggly brackets, we want to define our types. So I'm going to write down player, comma, AI. So these are the 2 types for the team data type. We have player and we have AI. Now, here I'm going to write an export variable, and this one is just going to be called team of type team. Now, if we look in the inspector, you'll see that team has a drop down where we can choose either player or AI. Okay, so we can easily choose for this unit, are they a player or are they an AI? Now, next up, we want to have 2 more variables. The next one is going to be one for our attack target. So attack target, which is going to be of type unit. This is going to keep track of which unit we are currently trying to pursue and attack. And then finally, we want to have an onReady variable, which gets called at the start of the game when the node is initialized. And this one is going to be a reference to our agent. So we'll call it agent of type navigation agent 2D. And this is just going to equal the nav agent, which we can drag in like so, okay? And that is all of the variables we are going to have for this script. Now, let's go ahead and define our different functions. Now, we're not going to fill out these functions just yet, but rather we are going to go ahead and just lay them out. So our first function is going to be the process function, which gets called each frame, and it has a delta parameter. And we'll write down pass for now since we don't want to fill that in. We are also then going to have a function called target check. Now, target check is going to be called each frame, and this is going to be in charge of basically detecting how far away we are from our target. If we are further than the attack range, then we are going to continue to chase after them. Or if we are close enough to attack, we are going to begin attacking, okay? And when we want to attack, we are going to call the try attack target function, which is going to basically check to see if we can attack them, and if so, it's going to deal damage. Then we're going to have 2 functions which are going to be in charge of setting either our move target or setting our attack target, because remember, if we right click on the ground with a selected unit, we will move to that position, but if we right click on an enemy, we're going to set them as our attack target and chase after them. So let's create those 2 functions. We're going to have a function for set move to target, and this is going to carry over a target parameter of type vector2, so a position. And then we're going to have a function called set attack target, which is going to have a target of type unit. Okay. Then we want to have a function for take damage, which is going to be called whenever this unit takes on damage, and that's going to have an amount parameter of type int. And then finally, we are going to have a function called die, which is going to be called when our health reaches 0, okay? And this is going to be an underscore because this is going to be called locally. Okay, so those are all the functions that we are going to have for this script. Now, in the next lesson, we are going to go ahead and begin filling out the bare minimum of what we actually need so we can actually start seeing our units moving around in our game. Okay, so thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be looking at finally moving our agent around, or moving our unit around, I mean. So the first thing we're going to do is go to our unit script, and in fact, there is actually one more function we do need to create that I didn't actually create last lesson. So that's going to be down here, and this is going to be called the move function, and we're going to send over the delta parameter here as well. Now, move is going to be called inside of process. So what we can do is remove the pass and just add in move here and sending over the delta. So what are we going to do inside of move? Well, basically what we want to do is move towards our agent target position. So if I go here and write down agent.target position, this here is the vector2 property that our agent is wanting to move towards. Now, we can set this whenever we want, and whenever we set this variable, it is going to generate a path along the nav region for us to move. So, in fact, let's go down to where we have the set move to target function, and all we are going to do here is basically, we are just going to go agent.target position equals target. And also while we're here, let's go ahead and set the attack target to be null, okay? Because if we are moving to a position, we no longer want to be moving towards a target unit. So now what we can do is with this target position variable, we then want to actually move towards it. But we don't want to just move towards it. We want to move towards it along the navigation path that has been generated for us, okay? So how do we do that? Well, inside the move function, what I'm going to do is I am first of all going to create a variable called movePos. This is going to be where we are trying to reach this frame. And we are going to call agent.getNextPathPosition. Okay, so what is this and how are we actually doing it? So I'm just going to bring up a little example here. Let's make a little obstacle here that we have to go around, and let's just say this here is our player, and this orange here is basically where we are trying to reach. Now, how do we actually path around it? Well, by default, we are just going to draw a straight line as that is our direction we want to move towards. But with the nav region, this is going to generate a path that would look something like this. Okay, so we have a point here. We then move over here to this point, and then we move down to the X. Okay, so what this get next path position function does is it's going to return to us the next path position that we want to move along. So for example, we start here, we then move along here to this path position. When we reach this path position, we are going to move over towards the next. Once we reach this one, we're going to move over towards the next until we have completed our path. So this function is essentially going to return to us the next path position we have to move towards. And once we get that, we then have to calculate the direction towards it. Okay, so which direction is that from us? So I'm going to create a variable here called moveDirection or movedir. And this is going to equal global position. So the global position of the unit dot direction to the move pos. So this is going to calculate a direction pointing towards that move position. And then we're going to create another variable called movement. And this is going to basically be in what direction and how far are we going to be moving our unit this frame. So this is going to equal to our move direction multiplied by our move speed multiplied by delta, okay? So move direction is basically just a vector with a length of 1 pointing in the direction that we want to move. Our move speed, we are then multiplying it by that so that we can actually change how fast we move. But the result of these two things is going to basically be the movement in terms of per second, okay? We want to turn this into a per frame calculation, and to do that, we are multiplying it by delta. So then what we can do is we can call the translate function, which basically just applies a positional offset to our unit, and we're just going to give it the movement property here. Now, if we go ahead and press play, you'll notice that, well, nothing happens, and that is because we don't really have a, we don't actually have a move position to go to just yet. So what I'm going to do is up here inside of the ready function, which is just going to be a temporary function. So we'll create the ready function. We can go set move to target, and we can give vector 2.0. Okay, so this is going to be trying to move to the center of the screen. So let's save that. Let's go back into 2D mode. Now our unit is already in the center, so I'm going to move them over to the right here, and let's see what happens when I press play. So when I press play, you can see our unit is going to move to the center of the screen. Now it's a bit slow, so let's actually pump up the move speed maybe to about 30. Okay, And you can see they're going to move to the center of the screen and stop there. They are shaking a little bit, but we'll get to why that's happening in just a moment. Now, if we move them over to the side of the obstacle here, what do you think is going to happen? Are they going to move straight towards the center, or are they going to move around the obstacle? Well, if we press play, they are indeed going to move around the obstacle, as you can see right here, which is amazing. And then they reach the center point and they stop. Well, kind of stop. Okay. So why are they shaking, and why are they kind of clipping through the navigation region here? Okay, we saw that our unit kind of curved around here, which is a bit unusual. We want them to go down to the bottom and then go up here. Well, that has to do with our nav agent 2D node. So let's go over to our unit scene, and what we're going to do is select the navigation agent 2D, open up pathfinding, and we want to look at these two properties here, path desired distance and target desired distance. Path desired distance, you can see it's right now set as 20 pixels. This means that when we reach within 20 pixels of our next path position, it is going to switch over to the next one. Now, why is this a thing? Why doesn't it switch over when we reach that path position? Well, generally when you're doing AI movement, you might have it as a physics object that is being pushed around the scene. They might be going very fast, taking acceleration and arcing corners. So if you set their desired distance to be 0 pixels, then that means they're going to be jittering back and forth between that position. But with us, that's not really an issue, so we can lower this number by quite a bit. And target desired distance is basically when they reach within 10 pixels of the target, that is going to be classified as completing the navigation. So what I'm going to do is I'm going to bump both these down to 5 pixels, so that should make our movement look a lot nicer. Let's press play and see how that works. So now our unit is moving right to the bottom, and they're moving around the obstacle as we see fit. Now, we still have this jitteriness appearing even though we set our navigation agent 2D, the target desired distance down to 5. Now, the reason why that is happening is because each frame, even if we have reached the target position, we are still trying to move our player. We're still trying to move our units, okay? And if we are on that 0 position, it's calculating the direction and then multiplying it by the move speed. So no matter what, even if we're standing directly on it, it is still going to have that direction vector be positive and try and move us in that direction. So for example, if we are standing here and our target is, let's just say, here, well, we are going to then want to move to the right, but we're going to move to the right in quite a large area, and then we're going to be over here. Then we want to move back here, and then we're going to be here, then we want to move back here, and you can see how that jitteriness can occur. So all we need to do is check to see if we have reached the target, and if so, we just want to stop calling the move function. So to do this, we are just going to go inside of process, if not agent.isReached target, is target reached, sorry. So if we have not reached the target, then we want to move. Otherwise, we don't want to move. So now if I press play, you should see we're going to move. And once we reach the target, we should stop calling that move function entirely. And that is going to make us nice and stationary, okay? So that is how we can set up the basic movement for our game right here. You can see it's not a lot of code really. We just have 3 lines calculating some vectors and positions, and then we are translating that movement. Up here in the process function, we are only calling the move function if we are currently not at our target position. If we are at our target position, then we don't want to do anything, but if we aren't at our target position, we want to move towards it by first of all calculating the move position, so where are we wanting to move to, then what is the direction to that position, and then how much movement do we have to apply to our position per frame, and then finally translate, which basically adds this vector to our current unit position. And then also we have the set move to target function, which basically just sets our target position on the agent, and once that is done, that will then tell the agent node to calculate a path to that target. Now in the next lesson, we are going to set it up so we can actually have player units. We can click on our player unit and move them around. Okay, so thanks for watching, and I'll see you all then.